In this video, we're going to be taking a look at Chapter 10, Chemistry of the Environment. If you haven't checked out any of my previous videos, please do so by clicking the links in the video description, or they will be displayed in the eye throughout the video. Let's get started. Okay, first things first, there are two tests for the presence of water. There is anhydrous copper 2 chloride, which changes from blue to pink when it comes in contact with water. And then there's anhydrous copper 2 sulfate, which turns from white to blue in contact with water. You do not need to memorize the equation, so don't worry about that. Okay, in order to test for the purity of water, you need to know that water has a boiling point of 100 degrees Celsius and a melting point of 0 degrees Celsius. So impure water will basically increase the boiling point, and impure water will melt below 0 degrees Celsius. So distilled water is used in practical rather than tap water because it has fewer chemical impurities. Why do we say that it has no chemical impurities? Because as soon as the water is exposed to the air, it will gain some chemical impurities. So you can't say it is completely pure. Okay, water from natural sources include substances like dissolved oxygen, metal compounds, plastics, and sewage. These also include harmful microbes, nitrates from fertilizers, phosphates from fertilizers, and detergents. Now, some of these substances are useful because dissolved oxygen is used by aquatic life for respiration, and some metal compounds provide essential minerals for life. However, some of these substances are potentially harmful. Like some metal compounds are toxic, some plastics harm aquatic life, and sewage contains harmful microbes that cause diseases, as well as nitrates and phosphates, which are found in fertilizers, cause deoxygenation of water and harm life. If you're a biology student, you'll know the exact same process of how nitrates and phosphates cause deoxygenation of water and harm life. However, you do not need to know the whole process for a chemistry student. Now, you do need to know the three key steps in the treatment of domestic water supply. First is sedimentation and filtration to remove the solids. So sedimentation is basically you're going to leave the whole bucket of water in like a clear kind of container so you can see all those particles that are more dense than water settle down, and then you're going to filter it out so it's like easily being able to filter. Then you're going to use carbon to remove taste and flavors, and chlorination to kill all the microbes. Now, we just did talk about fertilizers, but what exactly are fertilizers and what are they made out of? So, ammonium salts and nitrates are used as fertilizers, and NPK fertilizers provide elements like nitrogen, phosphorus, and potassium for improved plant growth. So, you don't need to know the exact functions of each and every single element in this. However, it is good to have a bit of knowledge. Now, common fertilizer compounds are listed over here. However, they will ask you, especially in MCQ questions, which of the following have a better chance of growth for healthy fruit or flower or healthy plants in general. And you need to choose the one with more elements that are improvable for plant growth. Okay, let's take a quick look at air quality and climate change. So we obviously know that clean dry air has approximately 78% of nitrogen, 21% of oxygen, and the remainder is a mixture of noble gases and carbon dioxide. Now, if they do ask you if all the air is made out of elements, that is false. This usually comes up in MCQ questions because carbon dioxide is not an element. It is made up of two elements. Now, there are sources of air pollutants. However, I think it'll be best if we use this cost specification for this topic because it is new. Okay, so carbon dioxide from the complete combustion of carbon-containing fuels, carbon monoxide and particulates from the incomplete combustion of carbon-containing fuels, methane from decomposition of vegetation and waste gases from digestion in animals, oxides of nitrogen from car engines, sulfur dioxide from the combustion of fossil fuels which contain sulfur compounds. Now, there are adverse effects of these air pollutants, which are limited to, for carbon dioxide, high levels of carbon dioxide lead to increased global warming, which leads to climate change eventually. Carbon monoxide is a toxic gas. Particulates are basically increased risk of respiratory problems and can possibly cause cancer. Methane has high levels of methane, leading to increased global warming, which leads to climate change. However, methane is not as dangerous as carbon dioxide because methane does disappear from the atmosphere after 12 years, but carbon dioxide stays there. Then, oxides of nitrogen, acid rain, photochemical smog, and respiratory problems. Sulfur dioxide causes acid rain. Okay, going back to our document, the greenhouse effect. So the greenhouse gases like carbon dioxide, methane, nitrous oxide, and etc. absorb heat that is reflected off the ground from the sun and is absorbed by heat, which is re-emitted in all directions, which reduces thermal energy lost to space and increases temperature on Earth, leading to global warming and climate change. So basically, the carbon dioxide held or traps all of, well, most of the energy that's supposed to be dissipated into space, which has been received by the Earth after it's emitted from the sun. And the carbon dioxide basically kind of traps all that, like causing the Earth to warm up more, hence the name greenhouse effect. You don't need to know all of the greenhouse gases. Okay, that is basically for today's video. I'm going to see you next time for chapter 11, which is organic chemistry. Please be sure to be there because this is one of the most challenging topics for IGCSE students. See you then. If you did like this video, don't forget to smash the like button and subscribe to give me motivation to make more videos like this for you guys. Bye!